Okay, so your launch today is all about writing recursive and closed form definitions for sequences. The first thing I see is that you have a word bank. So you have some different words to choose from as you write your sequence. You have closed form definition, arithmetic sequence, recursive definition, addition, multiplication, previous term, and common difference. So I know at some point in my response I'm going to be using hopefully all of these words. So getting to the actual question, it says a sequence is defined by f of 0 equals 2, f of n equals f of n minus 1 plus 7. So the first thing I'm actually going to annotate this equation and try to figure out what's going on. What does this mean? So it's Monday, it's been a weekend, so I'm going to use my cheat sheet just to remind me of how recursive definitions work. I can tell this is a recursive definition because it has like an f of 0 equals something. It has like these two parts, which makes it a recursive definition. So I can see that the f of 1 or the f of 0 is the initial term, and it tells me what I start at. So I'm going to go ahead and label that 2. I know the sequence that's described by this equation, it starts at 2. Then next I have, let's zoom in, next I have f of n equals f of n minus 1 plus 7. So again, looking back at my cheat sheet, it looks like this plus is the 3 to my previous, my common difference. So I'm going to go ahead and label that. Just to if I would actually write the sequence, it would look like 2 would be the first term, and then I would add 7 to get to the next term. So 2 plus 7 would be 9. And what I did there, I took the initial term, and then I'm adding 7 to get to the current term. 9 plus 7 would be 16, and then I could just keep going to write. But that's not really what the question's asking me to do. So to continue reading, it says Ms. Gattell writes an equation for the nth term of the sequence as f of n equals 2 plus 7n. Is she correct? Explain how you know. Okay, so the first thing I notice is that I have a 2 and I have a 7, and I notice that those match up with the 2 and the 7 that I annotated from the recursive definition. I don't that doesn't mean that I'm right. It doesn't mean that the 2 and the 7 are in the right place, but it does mean that it could be right. So what I'm going to have you do is go ahead and take your cheat sheet, and just for the purpose of class this week, it's going to be helpful to also make our own little cheat sheet for closed form definitions. So in sequences, we have two ways of writing them, recursive and closed form. For your closed form definition, it is going to look, we have f of n equals, and let's actually use the same sequence that we used on the first side. So we have 5, 8, 11, 14. Okay. So I can see my initial term is 5, and then to get from 5 to 8, that's adding 3. From 8 to 11 is adding 3. 11 to 14 is adding 3. So it looks like my common difference is 3, and my initial term is 5. So the closed form definition would be 5 plus 3n, where 5 is the initial term, or we'll use the same language, starts at 5, and then 3 would be the common difference. Important to know here is these could be switched, so we could have like 3n plus 5. The important thing is that whatever is being multiplied by the n, So whatever number is next to the n is the common difference, because that's telling you addition, same thing as multiplication. So just remember that the common difference is always going to be next to the n, and then the separate. It's just going to be a constant. Okay, so let's use my cheat sheet to solve this problem now. I'm trying to figure out if this closed form definition matches this recursive definition. Okay, so I see 2. According to my cheat sheet, that would be the number that starts at, so I'll say starts at 2. And then the 7 would be my common difference. And now I'm starting to see that my recursive definition does indeed match my closed form definition, because both definitions start at 2 and common difference is 7. So this equation means the same thing, it's just written in 2 different ways. So now that I've talked through this, I want you all to pause the video here, and I want you to practice writing out your own explanation. So you're kind of like summarizing everything that I just went through. Pause the video, and then you can play it and see what I end up writing as the final example answer. And then 16 plus 7 would be 24. Okay, so that's an example of how an answer could look that uses most of the words from the word bank. There are many different ways to say this. Important thing here is that you recognize that these sequence is the sequence 24. Add 7 to get to the next term. Okay, let's go over number 2. A sequence is defined by f of 0 equals -3, f of n equals f of n minus 1 plus 0.5. I'm going to go back to my recursive definition. I can see the -3 is going to be the starting term or the initial term. And then for this sequence, I'm going to be adding 0.5 to get to the next term. So for each term, I'm adding 0.5. I'm going to go ahead and do that. -3 plus 0.5 would be -2.5. -2.5 plus 0.5 would be -2. A little bit weird that the number we're adding and the numbers are getting smaller, but remember, if you think about the number line, negative numbers as you add, you're moving closer to 0. So -2 plus 0.5, -1.5, -1, -0.5, and then finally I'm going to get to 0, would be my last term. So I'm looking at the left-hand side of the number line, numbers less than 0. Okay, what I would like you to do now, you're going to go to Google Classroom, and on Google Classroom there is a survey called Launch Survey. So this is a pretty tricky launch. You're going to just tell me how you felt about it, and then that's going to help me with design the rest of class today. So again, just to repeat those directions, you're going to Google Classroom Math Lab page, and you're going to go to, I believe it's called Math Lab Launch. So go ahead, click on Math Lab Launch. You're going to take that survey, and then when you're done, you can come back and play this video again. Okay, so now that you've taken the survey, you're back, you've played the video. What you're going to do is use the survey, go to the next page of your handout. We're going to do some differentiated practice, mild, medium, and spicy. One of the questions on your launch was, I need more practice writing closed form and recursive definitions. If you strongly agreed with this statement, then you should work on mild problems to start. If you said, oh no, I don't really need much more practice, then this is where I want you to move on to the medium or spicy. So by the end of class today, everyone will try medium or spicy, but if you need more practice, start with the mild, and then we're all going to work our way up to these problems by the end of class today. Okay, we'll review a few of these with our partners and whole class. But for now, I'm going to ask you to work on these problems independently. You're welcome to keep your headphones in and play music, and then we'll come together at the end of class to review. Make sure to raise your hand if you have any questions, and thank you for your attention through this video. I hope you have a great day.